All right, this is section 4 of chapter 4. This is example 8. I gave you example 8 and 9 to do on your own. So first of all, what you had to do is to find the determinant of A, or the coefficient matrix. Second, you had once the determinant was found, which is 16, that means that there exists an inverse. If it was 0, the inverse wouldn't exist, then we can just stop right here. But the inverse existed, so we had to find A inverse, which is 1 over 16. We reversed 3 and 5, their positions, and took the opposite signs of -1 and 1. -1, -1. Okay? That's A inverse. What you don't want to do is multiply that determinant, or the outside scalar, by the matrix. What you want to do is multiply A inverse, which is here, this is A inverse, times B. B, they call it the constant matrix. So once you do that, all the way to the end, you're going to multiply A inverse times B, then you're going to get 1/16 times -32 over, and then -112. Then you multiply each term by the scalar at the end, and you end up with the solution -27. Example 9, find the determinant. If it exists, then we have an inverse. We find the inverse. Again, we don't multiply the scalar 1 over -9 or -1/9 until we multiply the matrices first. Multiply the matrices. Once we get the matrix combined and it's down to single entries, then we multiply by the scalar, and the solution is 3/7. All right, example 10. So we need to solve this system of equations using inverse matrices. So I'm going to move some stuff over here to make it a little bit easier to work with. All right, so we have x plus 1 equals 1, x plus y equals 1, 2x minus 3y equals 12. All right, so first we have to go ahead and put it in matrix form. So remember, whatever is front of the variables is what we put in the coefficient matrix. And we have times xy equals the constant matrix, or B, which is 1, 12. All right, so we have to see if a determinant exists. So we'll call it the coefficient A. So we're doing, remember, this is A times x equals B. Okay, A is the coefficient in front of the variable, so we have to find the determinant of A. So 1 times -3 minus 2 times 1, -3, -2 is -5. So there is a determinant. So now we can find A inverse. A inverse is equal to 1 over the determinant, which is -5, times, now we look at A, we switch -3 and 1's position, they switch positions, and then the sign changes for 1 and 2 to -1, -2, and they stay in the same position. All right, so that's A inverse. The final is to find x and y. It equals the inverse times B, which is 112, or the constant matrix. So the idea here is once you find the inverse, you multiply the inverse times the constant matrix, and then we'll find our answer. What you don't want to do is you don't want to multiply the scalar, the negative 1/5, until the end. So now we're multiplied two matrices together. We have negative 3 times 1 plus negative 1 times 12. Be careful. Make sure you put you can put most of your negatives in parentheses if you have to, so you don't make a mistake. Negative 2 times 1 plus 1 times 12. Okay? So you just got to remember that we have negative 1/5 out front times, let's take a look here. So this is negative 3 minus 12, which is negative 15. We have negative 2 plus 12, which is positive 10. Negative 1/5. Oops, excuse me. So now we're going to take negative 1/5 times each entry inside. So negative 15 divided by negative 5 is positive 3. 10 divided by negative 5 is negative 2. So our solution we want to put it in ordered pair form. X is 3, y is negative 2. So if you want to check your answer, you can plug 3 in for x and negative 2 in for y and verify that it equals 1 and it equals 12 on each equation, which it does. All right, let's go ahead and solve this system by using matrices. Make some more room here. All right, once you get these problems down, they're not that bad. So we have to create a coefficient matrix. Then we have the variable matrix. It's times the equals the constant matrix, which is 0, 4. Check to see if the determinant of A exists, or the coefficient matrix exists. 5 times negative 1 minus negative 1 times 1. Negative 5 plus 1 is negative 4. So it does exist. So now we can find the inverse. A inverse is equal to 1 over negative 4. The 5 and negative 1 switch places. Then we take the opposite sign of each of the other two. So that's a positive 1, negative 1. So we have the inverse. Now we take the inverse and multiply it by B, or the constant matrix. So we have negative 1/4, negative 1, 1, negative 1, 5, times 0, 4. It's not a lot of work once you keep on practicing over and over. It's just like any sport or any skill you want to do. So you have negative 1/4. Make sure you have the negative 1/4 still out there. I know I forgot to do it last time. And we're going to multiply negative 1 times 0 plus 1 times 4. Negative 1 times 0 plus 5 times 4. You get negative 1/4. So that's 0, 4. So we get 4. We get 0 plus 20. So that's, oops, excuse me for a second. It's not. All right, so this is 4 in here, and that's a 20. When we multiply 4 times negative 1/4, we get negative 1. 20 divided by negative 4 is negative 5. So our solution is -1, -5. So again, you write the system of equations into matrix form like we have here. Coefficient matrix times the variable matrix time equals the constant matrix. We find the determinant to make sure it exists. If it does, then we find the inverse. So you can say this is 1, 2, 3, and then the fourth step is the final step. And then the fourth step is take the inverse times the constant matrix, and you'll find out what x and y are. All right, do another one here for you. I'm going to go a little faster. I'm running out of time. So we got our first step is to write it in the matrix form. So we have -2, 1, 1, 1. X, y equals 5 and 2. So we wrote a matrix form. Check to see if the determinant exists. -2 times 1 minus 1 times 1 equals -2 minus 1 is -3. It exists, so we can find an inverse. So it's 1 over -3 times 1 and -2 switch places. The ones take the opposite sign, so now we have the inverse. So there's step 1, step 2, step 3, and then we take step 4, which is A inverse times B. Remember, the inverse is up a little higher. A inverse times B, which will equal to the inverse times the constant matrix. B is 5 over 2. Do not multiply that scalar out front, that fraction yet. So just leave it alone. So I have 1 times 5 plus -1 times 2 -1 times 5 minus, or we can just say plus -2 times 2. 1 over -3. So we have 5 minus 2 is 3. -5 minus 4 is -9. So when we multiply them together, 3 divided by -3 is -1. -9 divided by -3 is +3. So our solution in ordered pair form is -1, 3. Okay, so I guess you can call this the fifth step. So you have the first step is to write it in matrix form. Second step is determine if there is a determinant. If there is, you go to the third step, you find the inverse. The fourth step is you multiply the inverse times B. And once you do that, you will get your solution, and you write solution in ordered pair form. All right, last one. This is a sample common core example for the test. I'm going to pause it right here, and you guys give it a try. Okay, so I looked at this sample question from the common exam. Again, you have to do the stages, put it in matrix form, find the determinant, find the inverse if the determinant exists, which it does. You got 11 here. And then take A inverse times B, and you get 2 over 1. So the solution is roses cost versus, and then carnation cost. So the roses cost $2. All right, have any other questions? Please contact your teacher. Have a great day.